So this is my third year moderating the optical panel at the APSCC conference. The makeup of the panelists has switched out a little bit here and there. Looking forward to hearing updates from the industry from this past year. So the abstract I wrote for this conference, for this panel, is that the popular hypothesis remains that LEO infrastructure will continue to disrupt and revolutionize the space industry. And within that LEO ecosystem, mesh network connectivity remains a key fundamental underpinning, and optical communications remains the key technology enabler to make that entire LEO ecosystem promise come together. So we're going to check in on these key players today who are all aiming to provide real-time connectivity, discussing this past year's successes, the past year's challenges, and how various optical communication industry events impact their company's technical and go-to-market strategies. So I'll first ask, let's go down the line. Please introduce yourselves. And I think all of you still seek private capital to keep your companies going. So give us your 30-second elevator pitch on why Kepler, why Warp Space, why Transcelestial, why Skylum.
Okay. Yeah. Hi. Hi, everybody. I'm Wen. I'm actually the lowest part in the list, and we're doing this just to test you guys because it's almost lunchtime and it's no fun if we just follow the order, right? It's a space industry, never follows the right order. Anyways, I'm Wen. I'm the co-founder and chief strategy officer of Kepler. I was actually the chief technology officer, but technology got boring, so I switched over to tech, to strategy. Sorry, I meant. But no, actually, I think the team is doing extremely well. In fact, they understand the tech really, really well to the point where I'm now looking further forward into the future to look into the strategy portion. So to address what Rizwan has been asking is what Kepler has been doing for the last year. We launched a pair of satellites, and we actually demonstrated optical inter-satellite link on orbit, and now we're on our way to be launching our constellation in the near future, and then I'll talk about more about it during the session. But I don't want to take up too much time just right up front. I'll pass over to Hiro.
Right, thank you. So I'm Hiro. I'm Chief Strategy Officer, Warp Space Group, and I'm also CEO at Warp Space USA, located in DC. Warp Space is a Japanese company. We have 3 offices, one in Japan, actually 2 in Japan, 1 in US, 1 in Europe and Germany. And what Warp Space does is basically optical communication service provider, a solution provider. And we do have a plan to launch constellation in MEO. On top of that, we are providing several hardware and software which enables satellite operator to utilize optical communication. We realize that there is certain hidden issues or problems in order to basically deploy optical communication constellation there, and we found out that some of the hardware and software could help operators to quickly install the optical communication, and we are actually providing those solutions. And in terms of the fundraising, actually, we recently announced actually Series B funding in Japan. The more press release will come out soon, next week or so. So that's basically me.
Thank you. Good morning, everyone. My name is Jens Mišek, and I'm a head of space and defense at Transcelestial. Transcelestial is a space laser communication company founded in 2017 in Singapore by Rohit Jha and Mohammed Danesh. They are both sending very warm regards, and they are actively visiting investors abroad. So again, spot on with continuously trying to sustain or expand the business with fundraising. And if this is interesting, please also talk to me. I think we are a little bit different from the other companies on the panel, because despite having the vision and intention to use laser constellations of satellites to connect the next billion of people that currently have less than optimal connectivity experience. We started the technology and business on the ground. So we do have a terrestrial laser communication product. It is currently being serving more than 150 different customer sites around the globe. We are expanding in the last few months very aggressively in the US. We have been serving connectivity through lasers at the Coachella Music Festival with our partner, or now partner T-Mobile. We are active in the Southeast Asia region. So there's a lot of links in Thailand, in Malaysia, Indonesia. Customers, real people being served through laser links. And now, maybe throughout the panel, also we'll talk about what we did quite recently in space. So some first steps also towards space-to-ground demonstrations. Thanks.
Good morning, everyone. I'm Eric Moltzow. I'm the Chief Strategy and Commercial Officer of Skyloom Global Corp. And Skyloom was founded in 2017, so we're 7 years in, with the vision of deploying commercial data transport services in space, primarily focused on the Earth observation market. Several motivators that we'll talk about hopefully today on what drives that market. There's some obviously other areas that we serve, not just in the data markets, but also broadband and government. There's really two business lines that Skyloom has. First is the service deployment, which we're currently working on, all using optical links with a backup of Ka-band from geo to ground to geo-based deployment. And the second business line is devices. So optical communication terminals. We never intended to get into mass production on optical communication terminals, but it came our way with a lot of what we're seeing right now in investments with the Space Development Agency, as well as other institutional programs, as well as commercial broadband for the use of commercial crosslinks and so forth. So.
Thank you. And first, I kind of want to start with when, because at least in my opinion, the news that Kepler closed intersatellite laser links, I think, was the first commercial, not owned by an extremely high net worth individual, spacecraft service provider to have done so. So I think I'm correct there, but could you walk us through kind of just that experience of closing the links? What were major lessons learned, or was it easier than anticipated? So yeah, just walk us through kind of the weeks that led up to it.
Well, first of all, I'm very surprised that you ran through a net worth search of everybody in Kepler, because there's some pretty rich individual in there. I'm joking. Lessons learned. The optical terminal is really, really well done, well designed. Like, huge shout out to everybody in the optical terminal industries. Like, seriously, all of y'all, like, everybody spends so much time thinking about how to use it, how to calibrate it, how users will run into the different situations in the field. Like, we tested all of them before integrating, like, and choosing TSAT, to be honest. But it's actually, we were very surprised by the amount of, like, thoughtfulness and kind of like amount of time that people put into making the optical terminals very usable. Ultimately, when it came down to choosing the final one, it wasn't an easy decision to be made, to be honest with you. So some fun ones. During the testing, like, moon calibration turned out to be a lot more useful. This was from the operations person, just basically saying that once you've integrated the optical terminal, when you point to the sun, you actually hurt the receiver, but when you point to the moon, you don't. So you can actually use that to calibrate, like, the mounting of your optical terminal, which is kind of fun. Ease of operation is key. I think when the first optical terminal was built, the number of commands needed to point to a target, it's quite a number of them. But these days, it's pretty simple. It's like, you put in a TLE, it computes everything needed, and then it just does the pointing. So ease of use is very key. And finally is the accurate time synchronization across the platform. That's been one of the biggest challenges that we ran into when we were trying to basically make a very accurate pointing system. But ultimately, we were able to quantify the time delay from your start tracker to your onboard computer to your electronic units, everything. So that's also key.
Thanks. Eric, you mentioned kind of the various two kind of fundamental aspects of Skyloom. On the service side, so I think when you guys started, it was envisioned that you guys would be the service provider, customers come to you. You have a major partnership with Space Compass right now. Is Skyloom somewhat pivoted where Space Compass will be the lead in terms of the service provider? You're a key partner as far as providing the hardware for the service, or is there still an intention for Skyloom to have its own independent network in time?
Yeah, so Space Compass has been a really great partner with Skyloom for several years. And we're co-equal investors into the deployment of our services. We both bring strengths of the market between the U.S., European, and as well as Asian market because of the relationships that both parties have. So we work collaboratively together on the actual build out and deployment of what that service is going to look like. And we're co-equal partners in both the investment as well as the revenue share side of things.
Okay, thanks. Hiro, so Warp Space, you've been around, you're on a lot of panels, you're definitely one of the largest evangelicals of optical comm. But it's a little ambiguous as far as what is Warp Space's timeline, what's your implementation plans, where do things stand with reorbit, where do things stand with your optical terminal providers? So a little bit of color on that would be appreciated.
Sure. So yes, we are still building our satellites. We do have a plan to launch first satellite in 2026 or later. But we started this new service, like a solution. Basically, we've got funding from the Japanese government, several of them, for like a Minister of Economy and Communication to build some of the hardware to help basically optical communication more agile and also multi-protocol. And to be honest, our last 6-9 months, our focus was on that. So satellite bit is slightly slowing down, but we still do have a plan. We work with reorbit. That's official. So that's a timeline in terms of the constellation. But to be honest, and also we do work with Japanese Space Agency to develop some of the sensors, and also we've been doing a feasibility study for Artemis plan. Those we've done last 9 months as well. So we've been doing several other side tracks, but which all contribute to basically improving our MEO constellation, and that's still our main business to basically support Earth observation industry to downlink more data with less latency. I hope this helps audience understand.
And Jan, as you had mentioned, amongst this panel, you and Transcelestial have kind of a unique background with a deep experience in terrestrial implementation, tower to tower sort of stuff, I presume. So what motivates Transcelestial to look into the space market now? And if I recall properly, when you guys were first founded, there was an intention to be involved in space. I think you guys trenched back to focus on terrestrial first, so why the reemergence now?
It's absolutely correct observation. So even the name Transcelestial kind of implies that there was always the intention to go and provide connectivity in LEO, GEO, beyond Earth. So that was the vision of the founders. Now looking at how to get there, breaking it to technical steps as a roadmap, it turned out that a lot of these steps are both on the technical side, but actually on the business side as well, are overlapping with what can be done on the ground. And it can be done scaled up faster with much wider customer base. So there was the decision to actually not start with space, but start building terminals for ground, doing connectivity for telco companies, for internet service providers. We do a lot of connections for data center right now. Very rapidly emerging market is island connectivity. So connecting, basically using high bandwidth laser links over water, be it harbors, being islands. In Southeast Asia region, this is one of the most quickly growing markets, and it allows us to work with the. So I just make the turn back to your question. It allows us to also work very closely with the telco providers. So Globe Telecom, one of the largest telecom companies in Philippines, is one of our investors from Series A. So we work closely together to basically learn the business and bring the value to customers. Now the emergence of space. We have been doing work towards space demonstrations a little bit silently for the last 2 years. So we have had a space launch in February 2023 for space-to-ground demonstration. It did suffer some issues with the satellite bus that were not related to our payload. So we launched or plan to launch a follow-up mission that is delayed by one year. There's a PSL-59 waiting. So we are active in space, probably more than it seems active from the outside. But we do have some exciting announcement, I think, for early next year. So we are working on 2 projects with customers. We do have a payload acceptance review planned with a customer in Q1 next year. So hopefully more to come. Starting with space to ground, so high bandwidth space to ground, but also into satellite. So these 2 are kind of interesting programs. I can't tell more of the details, but in a sense there are things moving. And the moment we have some concrete results, we'll be very keen to announce it.
Thanks. Wen, so you've demonstrated links on your first 2 sats. How many lessons learned have flown back to your spacecraft design? And are you definitely glad you had 2 demo sets first? Because if you had gone up with a constellation of 8, 10, 12, you would have been challenged. So yeah, any status on the next constellation build out? And then how's the timing of that going to work? If you launch too early, you may not have enough customers to come on and use you. If you launch too late, you might not get good adoption. You now have ESA money to go work on some constellation work. You're doing some stuff with NASA. So a lot of inbound requests, maybe differing requirements, lessons learned on orbit. So how does this all go into your next constellation and timing?
So first of all, I can't tell you all of our secrets, because if I do that, my CEO will come and stab me in the back probably. But I can share with you some like simple lessons learned. I think I brought up ease of operations is key, but it's really, really important in terms of testing your system, in terms of, especially something really new, really keep it simple. We look past that a lot, and make sure you keep it simple. In terms of, I think you asked the question of the status of our constellation build out, right? So we're actually building out our production facility right now in Toronto. And that's gearing up for the first constellation launch by Q4 of 2025. This is lined up with the NASA timeline. The ESA timeline is planned to be 6 months to a year after that. And there's no real concern on timing because we've actually got a lot of really great results from the Pathfinder satellites that we built and launched. We were a little ambitious with the pair of satellites that we launched. And with that great ambition, we actually learned a lot more about how to operate a satellite of that size. What else? Yeah, I mean, our timeline currently is still Q4 25 for the first orbital ring. The second ring should be, about 6 months to a year after that.
And if I could add on a question, you look at being a commercial version of SDA protocols. I think the ESA requirements are actually more ambitious and higher throughput, if I remember properly. So is that going to be two different constellations? One is SDA compliant constellation, one's going to be higher throughput compliant constellations. How's that coming together?
That's TBD. I can't actually tell you because it's in active discussions currently. Because the main reason is that we are very much vertically integrated, and to switch between some protocols that are lower data rates and some higher data rates protocol, it's switching up hardware internal to the spacecraft, and it's not too difficult a task to do when you're the full designer and builder of the spacecraft. I think it all comes down to kind of like the difficulty in managing the different configuration of the satellites on orbit and the customers that come with it. So it's a TBD thing, yeah.
Eric, can you give us a status of your spacecraft first node build out and a little bit of thought into thinking about like when do the additional nodes get built out? Is the manufacturing on pause for those because you want to get the lessons learned on the first ones, or are you assuming all's going to be right and you have the other ones lined up to launch as soon as the first one launches?
Yeah, good question. So our target for our first node launch is at the end of 26. Right now for the service, this is for the what we call the Sky Compass service deployment. Sky being Sky Loom, Compass being Space Compass put together. At this point, in terms of the service architecture, infrastructure, the design is complete. So we have agreed upon what we call our critical design review. Right now, we're looking at trades and so forth in terms of the satellite itself. We have actually booked 50% of the capacity for our first launch. It's already gone. Regarding timing and so forth for the remaining nodes, our initial plan is 3 for servicing the Earth observation market. A 500 kilometer orbit. You only need 2 geosatellites to cover the entire LEO ring. Okay, but our plan is initial plan is for 3. Our plan is to launch every 2 years. So you can do the math on that starting in 26. One of the things that we find very exciting is that the technology is rapidly changing. So to your point about lessons learned, what we're seeing is the opportunity to really drive the envelope on the technology. One of the benefits Skyloom has is that we are actually developing the technology in-house. We're developing the devices in mass quantity, and we have an incredible engineering team that is building out the next generation. So for example, you can read online, we have an ongoing effort with NEC Corporation for a 100 gig terminal that's focused on LEO orbits, but we're looking at how we expand that for long haul distances. And so we will see where the technology maturation is on those because the larger the data rate, the more capacity that you can drive, the more terabytes per day that you can drive through the network. What we're seeing is, and one of the things that really surprised me when I came into this job and talking with the customer base, is how much data is actually being generated. The data demand is huge. so to keep up with that, we really need to be driving to the higher data rates in optical. In optical, we see is the only solution for being able to drive big data in and through space. And so that's the current plan.
Thanks. So Jan, Trans-Celestial's activities in the terrestrial ecosystem, I presume means you had an opportunity to assess a whole plethora of terrestrial communication networking standards, protocols, and you've probably had to balance that against standards going through fiber versus realities of what happens when you're dealing with free space, atmosphere, scintillation impacts, links breaking, resuming, all that sort of stuff. So I guess, what's been your experience on figuring out what is the best sort of standards or protocols for the atmospheric world? And have you had a chance to kind of assess the space industry, the SDA's protocols, what's been your experience? Is it better to have a standard protocol for, adoption from many different terminals, or has it been a leaning towards closed networks that are hyper-optimized for a given mission, right? In the space world, Kuiper and Starlink appear to have unique optimized protocols. SDA is pushing for a standard protocol. I guess looking back at your terrestrial experience, what's been your position on this?
That's a great question. Yeah, it's I think the terrestrial market, if I would kind of make the difference between the standard of how people transfer data or what kind of data they are expecting to use, how they format it, what is the sensitivity on, let's say, scintillation, packet drops, what is the sensitivity on bit error rate. It really depends on the market. So if I would think, or use case, so if I would think about, let's say, internet traffic, primarily by ISPs, as compared to, actually, if I would kind of think about this as a tree, this branch is even deeper. So if often we work with partners at different regions. Sometimes the ISP connectivity is in a urban environment, in a place where people expect very high standard connectivity. These are, let's say, corporate users that really have high availability requirement. Whereas when you compare it with providing connectivity to someone who is in a rural location, we do have villages in Malaysia that are connected through lasers primarily. So a full island connected with 10G link, it makes a transformative difference. So previously going through relatively limited bandwidth satellite connectivity, now the laser brings the backbone, and requirement there might be a little bit lenient. So that's about the data. Now if we bring telecommunication standards, so providing 4G connection, having services like, let's say, the mandated services by the government that imposes some service level agreement. So let's say for the police, the availability of the emergency communication over the link, that brings a further set of difficulties. Now this is on the data side. As of such, or as far as I know, there is no standardization attempt towards the FSO layer or the FSO side. So the terms of acquisition, the wavelengths for the beacons, the wavelengths to communicate, the error corrections. So these things are actually being more mature in the SDA standard, or more mature for the space. So it could be maybe it's actually relatively not a completely new phenomena that space can lead with setting us technical standards, at least on this side. So if the ground market progresses to let's say, if the SDA is a good starting point with the requirements, I'm not so sure. Some of the technical choices, in our opinion, lead to more expensive technical solutions on the terminal side. So it could be that some of the trade-offs might need to change. But yeah, I think that's kind of the view that we currently have.
Thanks. Are there any questions on Slido by any chance? Okay. Any questions from the audience? We got about 10 minutes left. Peter?
Right. So you guys are doing a lot of stuff, and I'm not exactly sure about a couple of things. So first, to start out with the easiest, which is Kepler, because they've been out and about. So my understanding is that what you're doing with ESA is up to 100 gigabit per second, not for a full ring, but just for a couple of satellites, each with 4 laser communications terminals. That's what the deal is with ESA. And that will be backwards compatible with SDA, despite the fact that it's 50 times more than the SDA calls for right now at 2.5. Am I correct?
So the SDA standard is launched on our first orbital ring, which is planned for next year.
Yep.
This new grant that we just got with ESA is planned to be 26.
Right, but the technical standard is still compatible with SDA, even at 100 gigabits per second and the ESA stuff.
So we're trying to basically make it backwards compatible. That's why it requires design time. It's actually 2.5 gig, and then all the way to 100 gig.
Okay.
So we're trying to make the 2.5 gig version backwards compatible all the way through.
Okay. And just to clarify, was it indispensable for you? There's been a lot of work, and you were very complimentary to everybody who's been working at SDA to develop laser communications terminals. So that was very generous of you. You had to choose one, maybe the only one that could produce at volume, but that's another question for another time. But was it indispensable for you, and I mean, I asked you this before, and I didn't get a clear answer, to have a test in orbit, or because your kit was already tested at the U.S. Naval Research Lab under SDA's intercompatibility rules, a lot of that has been done, so you didn't really need to test it in orbit. Or what you found out in orbit, just on the LCT side, not on the satellite bus side, was indispensable, and you wouldn't want to go directly to a commercial constellation without having gone through that testing.
The best way I can tell you to answer this is you don't know what you don't know. Like if you're gonna launch a constellation of like tens or hundreds of satellites, although theoretically speaking, like it shouldn't make a difference between testing the hardware on the ground versus testing in space. But given the opportunity, you will always want to at least have some similar environmental testing.
Okay. So go to Hiro, the same question then. What is your plan to get something in orbit before moving on to something more commercial as your constellation? Will you have a test bed in orbit before you move to an operational constellation?
Right, yes. We have a plan to do the testing in orbit next year, including our hardware. But OCT, we don't manufacture it. We work with third parties. So they will do the test in orbit with SDA. So, again, like same as when, as an integration system, how much tests we do in space. Since it's MEO, it's hard to do the many tests. So we may have to compromise some bit, but we definitely do in-orbit test before the.
And who is your OCT provider?
Well, one you probably know, but it's not. Mynaric was one.
Mynaric, okay.
And it's not exclusive, so we are also talking with other people as well.
Okay, because Mynaric's had issues with ramping up, as you know.
Right, yes. There's something I can talk and cannot talk.
That's right.
And
That's right.
The public information, right? There's some, or certain issues. But to be honest, for our contract, it's actually not a big issue.
Fair enough.
Yeah.
Okay, for Yan, so you're doing a lot of stuff ground to ground in islands and areas where there's an awful lot of rain. So I guess you don't, the links have to go on and off a lot. First of all, is that true, and how much of a perturbation has it been on the operational side? And second, if you want to move to space, because that's where the money is, or that's where the volume is, I guess, in terms of LCTs, right now, you're going to want to be SDA compatible despite the defects of that design. That's a question.
Great question. So on the first side, actually we do design the links on the ground. We work with the users, with the customers, in a way that we basically, based on their availability requirement, we design the distances of the link such that, let's say, if the requirement is 4 nines, 5 nines availability, then we limit the distance up to 2 kilometers.
Okay.
And this is based on the rain region, rain being the main attenuation factor. So we are able to do 4-9 availability links here in the rain zone P, so in tropics, let's say in Thailand, Singapore. So you can actually achieve almost uninterrupted connection up to 3 kilometers. So that's I would say typically the customers, when they test it themselves or when they see the data, they are quite surprised, because this is not the typical impression of optical communication. But even the very heavy rains here are typically not bringing the links down.
Okay. And Rizwan, just real quick one for Eric. So Skyloom is working with Honeywell to produce laser communications terminals as part of the SDA program.
Correct.
But I don't think you've tested anything in orbit yet, correct? Under the SDA.
I can't comment about that.
Really?
Yeah.
You're not allowed to say whether you've established?
Well, I'll say that we are producing flight units right now.
Okay.
Okay. There are other ongoing activities I can't comment about.
Okay.
We do have an optical ground station. We are expecting that we're going to be testing space to ground links as in the future, as well as space to space. I can say that we are launching next year on a number of different platforms, one of which is the ISS.
Okay. So on the space to ground, that's not SDA. That's another thing, right?
It's another customer, right?
Is that customer more amenable to your talking about it than SDA?
No.
No.
There's a number of different customers. It's just not just one that have interest to test from LEO to ground.
Okay. But you're testing next year a space to ground link.
That's our plan. Correct.
And you build both the orbital and the ground station?
Correct. Yes, we have an optical ground station on the roof of our headquarters in Colorado.
Okay. And that, I presume, will be using SDA protocols, SDA technical standards?
Correct. Yes.
Thanks.
Okay, got a couple more minutes here. So Transcelestial, a couple months ago we saw an announcement about collaboration with Axiom Space. They're doing, commercial LEO space station amongst other projects. So any color you can provide on what is that collaboration? What are the primary goals of that collaboration?
I think the first step that we decided after, say, our management had a chat about the goals of the respective companies, them being interested in space station for human space flight, but also to host data centers and provide compute in orbit. That's something that resonates with us, and I think from the experience from the terrestrial market, data centers do require a robust high bandwidth connectivity. Maybe not real-time connectivity, but very, very high bandwidth throughput. So we decided to explore this together. Transcelestial's position of having experience working with the telecommunication companies in the Southeast Asia, also with governments with locally allied governments for the US, basically allows us to also explore this angle of the stuff, to connecting allied governments, allied commercial or enterprise customers that with data center need in the region with the infrastructure that Axiom is building in space. So we are kind of currently exploring the commercial aspect of that, and the technical steps will follow.
I think I have one more question back to Hiro. So MEO has a nice middle ground compromise. You don't need as many units or nodes as LEO. It may not be as expensive, or the latency distance is less than GEO. But MEO doesn't really have an active commercial ecosystem. It's in the sense of you have a plethora of bus manufacturers that are building low cost for MEO. There's more new bus manufacturers for GEO coming about that Skyloom may be able to take advantage of in the future. So is MEO still where Warp Space wants to be?
Yes, yeah, that hasn't changed. So yeah, we've been doing a lot of feasibility study. I understand it's the hardship there in MEO, especially radiation, and that part I think that's one of the reasons we've been developing some of the hardwares. That's one of the biggest reasons doing this is basically radiation in MEO. Yeah.
All right, thank you. I want to thank my panelists, and I look forward to seeing progress next year.